This is chapter 10.2, Calculus with Parametric Curves. So if you want, go ahead and pause this video and write down all of these formulas. So these formulas are going to be given to you on an exam, so you don't have to memorize them. So you can see that most of these formulas are things that we've learned in Calc 1. So in Calc 1, we learned about first derivative, we learned about second derivative, we found about areas under the curve, we learned about arc length, and we learned about surface area. So a lot of these formulas should look, a little familiar. There's a couple things that are kind of changed now that we have parametric curves. I won't derive a lot of these formulas. Some of them I might, but the derivations are just basically in your book, so we want to be able to apply them. So the key to these formulas is actually not the memorization, and you won't have to memorize it. But I think what's the difficult part about this is using them. So even though we have the formula, sometimes doing the integration or doing the derivative might be a little cumbersome. So so what we'll start first is we'll start with the first and the second derivative, do a couple problems with parametric curves, and then we'll do on another video the area, arc length, and surface area, because those are going to take a little longer. So I guess the first thing to kind of start off with is just the first and the second derivatives. So parametric equations with first and second derivatives. So I wrote down on top the first and second derivative formulas for these parametric equations. They're not really difficult to derive. So if you look at the parametric, the formula for the first derivative, it's just basically taking the derivative with respect to t of the y divided by the derivative with respect to t of the x. So you can kind of think as the y as a vertical velocity and the x as a horizontal velocity, and it's just basically the change between them. So using the chain rule, you can kind of figure out why this is, why it is this way. So this is for the first derivative, okay? And then for the second derivative, this one's a little bit more challenging to kind of figure out. One thing to kind of know is that the second derivative is not this. It's not the second derivative of y and the second derivative of x. This is not right, okay? So this one is not correct, okay? So make sure that you don't do that. That's a common mistake that a lot of students make. One thing to know is that the second derivative is actually defined as the derivative with respect to t of the first derivative divided by dx over dt. So basically what you need to do is that once you find the first derivative, you're basically going to get whatever you get in the first derivative, you're going to plug it in here, you're going to take the derivative with respect to t, and you're going to leave the bottom part by itself. Okay, so that's basically the second derivative. Now, what do we use the first derivative and second derivative for? Well, the first derivative, we kind of use it for tangent, so the equations of tangent lines. So you can kind of, if you remember from Calc 1, we can use the slope, right, to find the equation of tangent lines. Okay, we can see whether they're increasing or decreasing, and we use the second derivative to test if something was concave up or concave down. Okay, so we're going to use the same methods that we've learned in Calc 1 to apply them in problems with parametric equations. Okay, so we'll start off with a problem. So let's say we want to find dy over dx and d squared y over dx squared. Okay, so this will be like maybe part A. And we have x is equal to t squared plus 4, and then y is equal to t squared plus 7t. Okay, so the first thing that we want to do is find the first and the second derivative. So let's start off with the first derivative. So the first derivative, dy over dx, is given to you as dy over dt divided by dx over dt. That's the formula. So the first thing that we're going to do is take the derivative of this guy with respect to t. That's just going to give me 2t plus 7 divided by the derivative of this x part, which is just going to give me 2t. Okay. At this point, you can just leave it as this. I think this working with this type of problem is a little bit better. Of course, if you want to go ahead and simplify it, you can just take 2t over 2t plus 7 over 2t. That's going to give me 1 plus 7 over 2t. You can do it this way if you want to as well. Although I think sometimes working with this is a little bit easier, especially when we start looking at other stuff. Okay, so that's going to be dy over dx. Okay, so we found that out. And if you want to go ahead and simplify it a little bit more, you can. And then you're going to take the second derivative of this. And basically the formula is going to be taking the derivative with respect to t of the first derivative and then dividing it by dx over dt. Okay, so the first thing that I'm going to do is I'm going to take the derivative, okay, of this part. So here, which one would you rather use? Would you rather use this one or would you rather use this one? Well, it doesn't really matter to me. I think that because when you're being asked for the second derivative, it might be easier to just go ahead and just use this, okay, if you want to, or you can just use the quotient rule for this. I'm going to go ahead and choose this guy. So 1 plus 7 over 2t. And then divided by dx over dt, which we already figured out that was just this 2t on the bottom. All right, so the derivative of this is just, so this is just going to go to 0. The top part is going to be negative 7 over 2 t to the negative 2 divided by 2t. And when I simplify it a little bit more, I'm going to get negative 7 over 4t cubed. So I guess there is some benefits to simplifying the first derivative to this part, especially if you want to find the second derivative. Of course, if you wanted to leave it like this, you would just either use the quotient rule or you can just bring that to the top and just use the product rule, okay? All right, so that's part A. So for part B, what we want to do is find this. So for which values of t is the curve concave up. So for this next problem, we have to use the second derivative, okay? And remember that in order to figure out whether something's concave up or down, we need to find the inflection point. So what we're going to do is we're going to take the second derivative, and we're going to set it equal to 0 to find all possible inflection points. So here's my second derivative. Negative 7 over 4t cubed is equal to 0. And remember that your second derivative equal to 0 is when you can have possible inflection points or when the second derivative is undefined. Okay, you can also have inflection points. So notice that if I multiply the 4t cubed over to the other side, you get negative 7 equals 0, which just doesn't make any sense. So basically, when it equal to 0, you got no inflection points. So we have to check when the second derivative is undefined. So it's undefined when the denominator equals 0. So that's 4t cubed equals 0. Clearly, t here is equal to 0. Okay? So this is a possible inflection point. Okay? So I'm going to write possible, because remember, an inflection point is just when it changes concavity. So now what we're going to do is we're going to go ahead and check points. Okay. Remember that if the derivative is negative, it is going to be concave down. Oops, second derivative. And if the second derivative is positive, it's going to be concave up. Okay, so the first thing to do is just plug in some values. So we know that the second derivative, let's just write, let me write it this way. So we have d squared y over dx squared is equal to negative 7 over 4t cubed. Let's plug in a number that's less than 0, so maybe negative 1. So I'm going to plug it in. So I'm going to get negative 7 over 4 times negative 1 cubed Okay, you're going to get negative 7 on top, and then a negative 4, which gives me a positive 7 over 4. So this is positive. So that means over here it's going to be concave up. Okay, now let's plug in a number that's greater than 1, t equals 1. So you're going to get negative 7 over 4 times 1 cubed. Obviously, this is going to give me a negative number, which is less than 0. It's going to be concave down. Okay, now if we look at the problem told us when is it concave up. So it only cares about concave up. So you can see that concave up is all of this guy. Okay, so it's concave up when it's from negative infinity all the way to 0. That's when it's concave up. We're not including the 0 because the 0 is when it equals 0 or when it's undefined. Okay. Okay, let's do another problem. Here, determine the values of t for which the parametric curve given by the following is concave up and concave down. And here are the parametric curves. X is equal to 1 minus t squared, and y is equal to t to the 7th plus t to the 5th. Okay. So same thing, since we want to find concavity, we have to first find the first derivative and then find the second derivative. So first let's start off with the first derivative. So we have dy over dx equals dy over dt divided by dx over dt. Okay, so we're going to start off with y. The derivative of this is just 7t to the 6th plus 5t to the 4th divided by the derivative of the second part, which is going to be negative 2t. Okay, and I think it would be good to kind of just simplify this since we have to find the second derivative anyway. So this would just be negative 7 over 2 t to the 5th minus 5 halves t to the cubed. Okay, so just to simplify it, since we have to find the second derivative, we found that it was useful in the second part, on the last part. So now let's find the second derivative here. So this is just going to be d over dt of dy over dx divided by dx over dt. So the top part is just going to be the derivative of the first derivative, okay? So this is going to give me what? Negative 35 over 2 t to the 4th, and then the other one's going to be negative 15 over 2 t squared divided by negative 2t. Okay, so now you see a couple of things. So let's first start off. We can simplify this a little bit if we want, but let's just leave it as is, because remember that in order for you to do this or figure out if it's concave up or concave down, we have to set this equal to 0. Okay, and notice that you're looking at two different things. You're looking at when the derivative equals 0 or when the derivative is undefined, the second derivative. So when it equals 0, if I can move this bottom part to the other side, and that's just 0. So then I'm left with negative 35 halves t to the 4th minus 15 over 2 t squared equal to 0. Okay. So here what we can do, we can factor out a t squared, and then we can actually factor out a negative, and what else can we factor out? We can also factor out maybe a 2. So we can factor out a negative, we can factor out a t squared. We can also factor out an over 2, and then we can also factor out a 5. Okay, and then here we just are left with a t squared, and then we're left with a 7. And then here we're left with we took out a plus. We're left with no t. We got rid of that. We get a 3 equals 0. Okay, so notice that now we're going to set both of them equal to 0. Okay, so this one's going to give me t equals 0. I get 7t squared is equal to negative 3. This is going to give me an undefined solution because it's a squared. When we take the square root, we're going to get undefined, so there's no real solution here. No real solution, only imaginary. And now, so we only got t equals 0. Here, when it's undefined, it's basically when negative, the denominator is equal to 0. So we get negative 2t equals 0, so t equals 0. So basically, you can just see that t equals 0 is basically where we're giving a little bit of issues. Okay? So let's go ahead and take a look at 0. And now we're going to use the second derivative test. So if we go to our original problem, okay, so negative 32, oops, negative 35, t to the fourth minus 15 over 2, t squared, that should be an over 2, divided by negative 2t. I think I got that right. Yeah, okay. So now all we got to do is we want to be able to put a number in there. So we're going to start off with t equals 1. Start off with t equals 1 and t equals negative 1. Okay, so I'm going to plug in negative 35 over 2, 1 to the fourth power, negative 1, minus 15 over 2, negative 1 squared, divided by negative 2, times negative 1. You can see that this is going to be, the top part is going to be a negative, okay, and then the bottom part is going to be a positive. So you can see that you get a negative here, and negative means concave down. And then we're going to do it when t equals 1. So we're going to write negative 35 over 2 times 1 to the fourth minus 15 over 2 times 1 squared, divided by negative 2 times 1. The top part is going to give me a negative. The bottom one's also going to give me a positive, which gives me a negative. So basically, this is concave down also. Okay, so you always want to check both of them. Don't assume that it's always going to be alternating, like in this case. So here, concave up. It's basically never. Okay, concave down is basically from negative infinity, so all the way here, all the way to 0, union 0, all the way to infinity. Okay.